Well, here we are, final day. Hopefully, so the second half is always congratulations if you got 49 stars, you get a 50th star. So let's hope this first part's not so bad. The expedition reaches the extraction point, several large hot air balloons, cruise quickly. Okay, fuel heating machine, new addition to the process, and this mountain was a volcano. Bob needs a total amount of fuel that will be processed ahead of time so it can correctly calibrate heat output and flow rate. Okay. Amount is simply the sum of the fuel requirements of all the hot air balloons, and those fuel requirements are even listed cleanly on the side of each hot air balloon. You Sydney elves will have no trouble adding up some numbers and are about to go back to figuring out which one's yours. Tap on the shoulder. Apparently the fuel requirements are numbers written in a format the elves don't recognize. Predictably, they'd like your help. Make a list of all the fuel requirements, but you don't recognize the number format either. Fortunately, Bob is labeled with a support phone number. More than one burner? No problem. You just need to add together our special numeral analog fuel units. Patent pending. Way better than normal numbers. Snafu, nice. Sort of like normal numbers. You know how starting on the right, normal numbers have a ones place, tens place. Well, the digit in each place tells you how many of that value you have. Snafu works the same way, except it uses powers of 5 instead of 10. Okay, starting from the right, you have a ones place, a fives place, a 25s place. Yep, sure. You then ask why some of the digits look like minus or equals instead of digits. I never did ask the engineers why they did that. Instead of using digits 4 through 0, the digits are 2, 1, 0, minus, and double minus. Okay, so because 10 in normal numbers is 2 5s and no 1s, in Snafu it's written as 20. Since 8 is 2 5s minus 2 1s, it's written as 2 double minus. Interesting. Sorry, I have to cough. My apologies, I didn't want to cough in your ears. Okay, so you can do it the other direction too. Say if a snafu number 2 double minus minus 0 1, that's 2 in the 625's place. Double minus. Okay. So that's 976. I see here you're connected via our premium uplink service, so I'll transmit our handy snafu brochure to you now. Okay, sure. Let's see. No way the fuel or any fuel would work in those conditions. There are only a few places. And where did you say you are right again? A few drops of a snowflake-shaped container in one of the fuel tanks. Thank the support representative and disconnect the call. Based on this process, the snafu numbers in the example above can be converted to decimal numbers as follows. In decimal, the sum of these is 4890. As you go to input the number to Bob's console, you discover some buttons. Instead, you have those. So I need to convert them back into snafu. So this is, it is interesting that it's 5's place, but it's done 2 through -2, right? That's obviously the difficulty here. So first thing we need is we need a converter, right? And we say, let's say long from snafu string value, right? And then we're going to need string to snafu of a long value, right? So this is going to be fairly straightforward on the from side. For each, let's see, place is going to start as the 5's place. And then for each of our digit and value reversed, right? We want, let's see, this, which is mapping is a new dictionary of char to longshore, which is going to be double minus is -2, minus is -1, and then 0 is 0, and then 1 is 1, and then 2 is 2. All right, so from Snafu, it should be fairly straightforward. The result is 0 long, right? So we're going to say for each one of these, result equals, let's see, every time we take a digit, we need to multiply it by its place. So result plus equals, let's see, place times mapping of the character. It's mapping of the digit, right? And then we would just return the result. And then here we're going to go for each of our line in data, result plus equals from snafu for the line. So let's get the result first. Just going to comment this out because it's not implemented yet. Let's make sure that we got the correct number coming out. So that's 130. That doesn't sound right. I missed this part, which is place times equals 5. So 24,450, right? 4890. What did I do wrong? All right. So we're going to do value. Var value is this. Console write line equals value. Let's see what I'm doing wrong here. So this should be 1747. That's interesting. Oh, yeah, that's weird, right? Let's do it by hand. All right, so let's get our calculator out here. So we've got 2, right? So you go into memory. Then we've got -1 times, oh, you know why? Place has to start as 1, not 5. Right, that's better. 1747 totals 4890. So how do we reverse this? So we need to return a to snafu of the results, right? So we don't have a to snafu yet. So really what we're looking for, what we normally do is we take a modulus here, right? Knowing that, for example, a single digit of snafu is going to be anywhere from -2 to 2, as opposed to -2, -1, 0, 1, 2, right? As opposed to 1, 2, 3, 4, 5, right? So what is the easiest way to do this? Because it's 3 to 7. So the range we're looking for each one of these is 2 off, right? So this would be 8, 9, 10, 11, 12, right? So I think the easiest thing to do would be right, what would so 1 double minus would be 13. Also, what's our real input look like? Bunch of numbers, looking kind of like 12-ish digits long. So one of the things we could do is while value is greater than 0, actually, let's take another quick look at our puzzle input. Do we have anything that looks like it's a negative number? The only small ones we see, only single digits I see are like 2. Wouldn't make sense for anything to contain negative fuel, so that I think that's a reasonable assumption. So we're looking for sort of like the biggest yeah, normally I'd use divide and mod. Doesn't really work, does it? What do we think the biggest one of these is? That looks pretty big right there. Let me pull this data in. let me start trying to make some assumptions about, whoops, I copied instead of pasted. Let's try that again. Biggest is going to be, let's see, return something, get rid of this for the moment. Biggest is going to be 0, right? And then biggest is math, max, biggest, and value, right? And then console, right line, biggest. And then, yeah, let's just get rid of this for the moment. Overflow. We had an overflow. Interesting. Oh, that's because place is an int. Right, that's no good. Okay. So that's our biggest number. I'm going to stash that over here for a moment. You can come off screen. We'll ignore you for the moment. All right. Let's go back here. What is this number in base 5? This is decimal. There's got to be an easy way for me to Google this, right? Give me a new window. Base 10 to base 5. Perfect. So that's our biggest base 5. So that's that in base 5. Which means we need 1, say we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need 5 to the 19th. All right, so that's what we're going to call the biggest number is 5 to the 19th. Let me grab my calculator. 5 to the 19th. That's this. We'll copy that. We'll put that up here. Yep, that looks entirely reasonable. That's where we're going to start. All right, so our start is this. And we're going to say, let's see, while value is greater than 0, what we need to do is we need to sort of isolate. Actually, let's do this. Exponent is 19, right? Let's see, our biggest number that we can give for this value would be, what is the right way to do this? I guess it would be that that massive number minus 2. But really, like, how am I? There's got to be, oh man, this problem is harder than it seems like on the surface. There's got to be a trick to this problem, right? I mean, there's got to be. All right, let's throw you over there. We still got our browser up here, right? Base 5, but with -2 through 2. Is there an easy way for me to just do this by adding 2 to the number? All right, let me see if that works. So if I have 3 and I add 2 to it, it gets me 5. That gets me to the next digit, right? So if I add 2 to the number, all right, so how do I say I got 7? If I add 2, that gives me 9. That doesn't help me, right? No, if I have 8, because 8 is where it transitions, right? 8 plus 2 is 10. So can I add 2 and do the modulus and division and then subtract 2 again? Feels like maybe I can, but I don't know if that's actually going to work or not. I don't know. Let's give it a try. Let's say we do this, which is also convert is going to be to snafu of the value. And we're going to say if convert is not equal to the line, then we're going to do a throw new invalid operation exception, expected value to be line, but was convert. So then let's start doing this. Let's try this, right? Var result is going to be a string, is going to be a new, probably it goes backwards, right? So let's do a stack of char. We're going to say temp value is value plus 2. Let's say we're going to say the 5s. Let's see, the least significant is going to be temp value mod 5. Result should be temp value divided by 5 minus 2 again, right? Minus 2 again. And so this is also going to be the least significant, which is this minus 2. And then we're going to do, let's see, we'll call you remainder, not result. We need this dictionary to be reversed, right? And then reverse mapping is mapping to dictionary KVP value to KVP key, right? And then result push the reverse mapping of least significant right? And then we're going to do this, which is going to be, let's see, result text is a new string builder. And then every character that comes out for each var c in results, result text append c return results text to string. All right, let's see if this does what we think. Would help if we use the remainder, right? The value is this. We don't have to call it the remainder. It was 1, 2, 2, 2. So we got the 2. $17.47. Should we just convert it to base 5 first and then move it around? That doesn't sound right, though. Does not sound right. Base 10 to base 5. All right, so we have, what was the number? The number is 1747. All right. So 23442. All right, that's obviously not right because that would be a 0. So that's not right. Yeah, like if I was to do this 23442, let's make sure my base 5 logic is right. 442, like let's not do it like this. Let's do it like this instead and say temp value. No, we don't need that. Result push 0 plus the value mod 5, right? And then value divided by equals 5. I guess we have to make that into a character. Is that what you're upset about? That's probably what you're upset about. Got an explicit cast. Okay, so that means, sure. Means you probably don't care about that or that, right? So let's make sure that I get 23442. So my base 5 logic is correct. So let's see what happens here. Let's just walk through it and see what's going on here. Comment that back out. All right, so we have a value of 1747. So we add 2 makes 1749, right? The least significant of that is 2. Okay, now the value is temp value divided by 5 minus 2. Is that right? Do I do the minus 2 then, or do I do it just value divided by 5? What if I just did value divided by 5? Let's just go ahead and do some of these. Oh, hey, look at that. That is 2 equals minus 1 equals 0. 2 equals minus 1 minus, okay, so that's what it was. I wasn't supposed to, subtract anything. So let's go ahead and do this. We don't care about this. We certainly don't care about biggest anymore. We certainly don't care about that because we're going to trust that. So let's get our answer. This appears to be our answer. Right, and then let's see if that's correct. It's good. Part 2. Hot air balloons, only 49 starts to go. Let's start the blender. 50 stars, all right. So, congratulations to us. uh, Thankfully, day 50, or day 50, problem 49, day 25, was actually not too bad. And I will be honest, I'm now looking at this. I'm going to go back to this screen. I don't think I've ever seen the little moving balloons. Like, I don't think I've ever seen them use moving graphics before. I'm kind of curious what happens if we go back to net last year. Was there anything moving last year? Oh, there were things that were moving last year, very subtly though. So I don't think I saw them. What about the year before? Because I've only done this 3 years. Oh yeah. Oh yeah, I definitely remember that. Okay, so things have been moving for a while now. Cool. Anyway, that's it. That's day 25 in the bag. Thanks for hanging out. I'm glad for it to be done. I've told some people I don't know if I'm going to do this next year, so we'll see. Maybe I'll be back next year, maybe not. But for all of that, I want to thank you all for hanging out. See you next time.